Welcome to this lesson. In this particular video, you're going to go through the introductory aspect of differential equations and what you're supposed to know about what differential equation is and certain things, okay? And then we'll take it from there. So, differential equation, an equation containing the derivatives or differentials of one or more the dependent variables with respect to one or more independent variables is said to be a differential equation. Now, what at all is a dependent variable? What is a variable, right? I mean, the dependent variable here, what it means in a normal term is that it depends on something. It's just a variable. Variable means something that can change, right? We can represent it in different ways. Most of the cases, you can say y is the dependent variable when you have a function says y equals 2x plus 5. Y here is the dependent variable because it depends on this x. Whatever x you put here, you get a y. And then here, x becomes the independent variable, okay? So that's the simple example I can give. I can give another example like u is equal to 2t, meaning u is a dependent variable, t is an independent variable, because for every t you pick, you get a new u. So for you to get a new u, you need to know t. So u depends on t, right? So that is dependent and independent variable. So when you have an equation that have equation containing the derivatives or differentials of one or more dependent variables, right? So you have maybe dy, its derivatives, right, with respect to an independent variable. So dy here, y is the independent variable, and it's an equation maybe plus 2t equals 0. So this equation is a differential equation because it contains a derivative of y with respect to the independent variable t, right? That's the actual definition of differential equation. And sorry about that. We say we classify differential equations by these properties, right? So before you can classify a differential equation, one, you can either say it is ordinary or partial. I mean, I'll talk about the partial. So we classify that by type. By type, we have ordinary and partial differential equations. What is an ordinary differential equation? Equation that contains only ordinary derivatives. What we mean by ordinary derivatives of one or more dependent variables with respect to a single independent variable. What we mean by ordinary derivative is that you have just the derivative of the dependent variable with respect to the independent variable, one or more, right? It can also be this type, right? If you look at the other parts, this one, it has two dependent variable, but the independent variable here is the same thing. It's just one, okay? So these are what we call the ordinary differential equation. You realize you only have just ordinary derivative. What I mean by ordinary derivative is we don't have any partial derivative here. So if you're familiar with partial derivatives, you understand what I'm talking about, okay? Another example you can think of is this one as well. D squared y dx squared minus 2 dy dx plus 6y is equal to 0, and that is ordinary differential equation, okay? Now partial derivative, that is by type, we have two, ordinary derivative and partial derivatives. And the partial derivative or partial differential equation, on the other hand, is an equation involving the partial derivatives of one or, so this is very important, the partial derivatives, right, of one or more dependent variables with respect to two or more independent variables, okay? So here in partial differential equation, you realize the operation here is partial u partial y. You see a del, right? You don't see just du dy. This is different. So one of the ways you can see that this is a partial differential equation or ordinary differential equation is the symbol. In partial differential equation, we have this symbol, the del u, del y, or as people call it partial u, partial y. And then in the ordinary differential equation, you have du, that is the total derivative, du dy, okay? So these are what we call partial derivatives. And we have this example, that one, this one as well, okay? So just like I said, the difference between the ordinary and partial derivative is ordinary and partial differential equations is that in partial differential equations you have partial differentiation or partial derivatives happening in there, in ordinary differential equation, you have normal derivatives that you know happening in there. Okay, so now let's go to the other classification. We have classification by order, and by order we mean the highest derivative term you have in the differential equation. Okay, so the order of the highest derivative in a differential equation is called the order of the differential equation. So here, this is the first order. Why? Because the highest derivative we have here is just one derivative, just one of them, right? We don't have the second derivative there, we just have one. Now second order because we have the second derivative in this second example, and this is a fourth order because this is a fourth order derivative, and this is a partial differential equation. These are just ordinary differential equations. And in classification by order, we don't care whether you have ordinary differential equation or partial differential equation. The most important here we look at is the order of the derivative, right? So that is it. Now we have another one, classification by degree. By degree we mean the power of the highest order term, right? So this is a first degree differential equation, right? Ordinary differential equation. And this is because the power of the highest order here is 2. So this is a second order derivative, but the power of the highest order here is just 1. So this is a first order of degree 1. Sorry, this is a second order derivative of degree 1. Okay, on the other hand, if you look at this one, this is a second order derivative, but the degree here is what? 3. So this is a third degree differential equation, right? This is a third degree ordinary differential equation, right? So the power of the highest order is what we use for the degree of the differential equation. Sorry. So you can think of this as so if let's say I had something like d squared y dx squared plus maybe d fourth y dx to the power 4 to the power 2, right, equals 0. This is of degree what? 2, and then the order is 4, right? But the degree is the power of the highest order, right? That's what you look for. Let's go to bilinearity. We can classify a differential equation as linear or non-linear. Now we said it's linear if, what can we say, if the dependent variable and all its derivatives are of the first degree. What it means is the dependent variable y, or maybe if in your case you have a u, the power should be 1, or its derivative should be having a power of 1. So if you have a second derivative, d squared y dx squared, and then there's a different power other than 1, let's say 3 here, then this is non-linear because the power here is 3. Now when you have the power to be 2, this is still non-linear, but if the power is just 1, then this is a linear because the derivative should be of power 1 or first degree, right? Now each coefficient depends on only the independent variable. What we mean by that is, if you look at these examples, right, I mean these 3 examples, all these ones, you realize the coefficients here, this is 2, right? This is not dependent on y. 2 is just a number, so the coefficients here in all the equations should be dependent on only the independent variable. 2 here is just a constant, so actually you can even mention that it doesn't depend on anything. On this side, this is x cubed and it depends on only x. This x squared depends on only x. This is 3x, depends on only x. It doesn't depend on the dependent variable y, right? No transcendental functions involving the dependent and its derivatives. What I mean by transcendental function is the nonlinear functions like log function, the trig functions, the hyperbolic functions as well. Okay, so these are what we mean by transcendental functions. So all your equation, I have a transcendental function e to the x here, but it depends on only the the independent variable and not y, right? So this is e to the x. It is okay with us because we don't have e to the y or e to the derivative involving y. Now if you go to the nonlinear part, if a or b, or c for linear is violated. So first, if a degree of any of these, how do I call it, the dependent variable and its derivative is not 1, then you can say is nonlinear. So here this is nonlinear because of why? Because we have the coefficient of y prime prime depending on y, or depending on the dependent variable, right? So that violates property B. If you go to this one, this is of degree what? 2. The power of y here is 2, so it violates property A, right? If you come here, this you have a sine y here, so this is a transcendental function in terms of the dependent variable, so this violates the property C. Of course, if you have something like y prime prime plus 2y prime then squared equals 0, this is violating property 1 because the degree here of y prime is 2, right? The degree of each one of them should be just 1, right? So these are the introduction to differential equation. We're going to talk about solution to the differential equation in the next lesson. I only just go through everything in differential equations, starting from normal ODEs to partial derivatives, right? So partial differential equations. So stay tuned as we explore the journey, or we go through the journey of differential equations together. See you in my next lesson.